Thank you for joining today's session on fraud detection at scale. I'm here to share how TigerGraph is helping organizations fight back against the rising tide of fraudulent activity using graph technology. My name is Sebastian Mansell. I'm Senior Director of Product Management here at TigerGraph, and I lead our Savannah Cloud product offering, which brings together the power of graph technology and the scalability of cloud. Sam Zoe is my engineering counterpart. He has prepared a pre-recording demo highlighting the fraud detection capabilities in Savannah, and that we'll get to see a little bit further down in the presentation. So let's start by defining what we mean by transaction fraud. Fraud can take many forms, ranging from stolen credit cards used before they're reported, to hacked accounts where personal information is used for unauthorized transactions. It also includes chargeback fraud, where a customer disputes a legitimate transaction, and online vendor fraud, where criminals impersonate suppliers to issue fake invoices. Now, while the methods vary, the outcome is always the same: significant financial loss. And today, we're here to show how graph technology, powered by TigerGraph, helps uncover hidden patterns and relationships so you can detect and prevent these types of frauds more effectively and in real time. Credit card fraud in particular is exploding. By 2026, global losses are projected to surpass $43 billion annually. So this isn't just an inconvenience. This is a global crisis affecting consumers, banks, and businesses alike. And the scope of the problem is staggering. In the US alone, direct losses reached $29 billion in 2023. But when you factor in hidden costs like investigations, chargebacks, lost sales, and customer churn, the real impact is closer to $40 billion. And globally, the picture is even more dire, with losses expected to reach over $400 billion in the next decade. And credit card fraud has affected a substantial portion of the US population over time. According to a 2025 report by security.org, approximately 151 million Americans have been victimized by credit card fraud at least once in their lives. And this figure represents over 63% of US credit card holders. And to drive this closer to home, we're going to take a quick poll. We'd love to hear how many of you have been affected by credit card fraud, and to see how widespread the issue really is. And we'll come back with the results of those polls in a little bit. So before we dive into the solution, it's important to acknowledge why traditional fraud detection systems often fall short. First, there is the issue of speed and scale. Fraud detection needs to happen in real time across massive volumes of data coming from multiple systems. Ensuring that data is accurate, complete, and timely while integrating it from multiple sources is a serious challenge for legacy tools. Second, we face the problem of false positives. When detection rules are too aggressive or rigid, they can incorrectly flag legitimate transactions. And this leads to frustrated customers, delays in processing, and ultimately loss of trust in the system. And third, traditional systems struggle because of limited fraud detection capabilities. Fraud schemes are constantly evolving. What worked 6 months ago may no longer be effective today. And static rule-based approaches or basic ML models often can't keep up with the speed and creativity of modern fraudsters. These are the gaps we're solving with TigerGraph. We're bringing context, speed, and adaptability into the heart of fraud detection. Now, traditional machine learning models often plateau at about 60% detection accuracy, leaving far too much fraud undetected. And that's where TigerGraph comes in. Our solution delivers a 20% increase in fraud detection rates, helping organizations catch more fraudsters in real time, a 300% boost in investigation efficiency, thanks to intuitive graph-based exploration that drastically reduces time to insight. And the bottom line, over 100 million in fraud savings per year for top-tier banks that have deployed Tigergraph. What's more, our platform handles massive data sets with ease, over 10 terabytes and growing, something that's simply not possible with most conventional solutions. And Tigergraph processes hundreds of millions of transactions per day, with fraud detection queries returning in under 80 milliseconds. That is a transformational leap in speed, accuracy, and scale. Now, let's walk through the architecture of our fraud detection solution. On the left side of the diagram, we begin with data ingestion from both real-time streams and historical data stored in data lakes. This data is continuously streamed into Tigergraph, where it's modeled in a graph-native schema that captures the complex relationship between entities like cards, transactions, merchants, and parties. Once the data is in graph form, we generate ML features using Tigergraph's built-in algorithms such as PageRank, community detection, and shortest path. These features capture important patterns and relationships that would be difficult or impossible to detect using flat tables. These signals are then passed into a downstream machine learning model, typically something like XGBoost, random forest, or logistics regression. Importantly, the end-to-end process is fully automated and it happens in real time. There's no human in the loop reviewing the data or making decisions. That would just be too slow. I said the model produces a fraud score for each transaction, which becomes the key output of this pipeline. The score is then used to automatically flag suspicious transactions, often in milliseconds, ensuring that fraud is caught early without introducing friction for legitimate users. And that balance is really critical. Fraud makes up roughly 1% of all transactions, which means your detection system must be precise. It must scale in real time to avoid impacting users at the point of sale and or online checkout. Now, the graph schema is the heart of our graph model. We represent every transaction and every party involved, cards, merchants, and people, as interconnected nodes. This rich schema lets us analyze not just the transaction itself, but its broad behavioral context, shared devices, reused cards, merchant card loops. And this graph is what unlocks powerful feature engineering, graph algorithms, and ultimately more accurate fraud detection. So before we run community detection or path analysis, we enrich the graph to uncover latent relationships between merchants and cards. Merchant network detection creates edges between merchants that have processed the same card. The more shared cards, the stronger the connection. And this helps surface merchant clusters that may be colluding or part of a fraud ring. Card network detection connects cards used at the same merchant, weighted by frequency. This reveals clusters of cards that may be stolen, synthetic, or controlled by the same actor. So importantly, Graph enables you to go beyond evaluating single nodes. It lets you assign risk at the community level, which enhances precision and context for fraud detection. Community detection is a critical tool to uncover fraud because fraudsters often form coordinated rings that behave like tightly knit networks. And these communities are not predefined. They emerge organically, and it's up to financial institutions to detect them before significant damage is done. Using algorithms like weighted WCC or Louvain, we can identify clusters of cards, merchants, or users that are more densely connected to each other than to the rest of the network. And these structures often reveal a group of merchants that primarily transact with the same set of cards, or a card interacting with entities far outside its normal behavior. Another powerful signal in graph-based fraud detection is proximity to known fraud. Now, this is intuitive. If a transaction is only a few steps away, meaning a few hops in the graph, from a previously confirmed fraudulent transaction, it's statistically more likely to be suspicious. This is known as shortest path length. We calculate this path for every transaction, measuring how quickly fraud could have propagated through shared accounts, devices, or overlapping behavior. So, for example, a short path might reveal collusion between users or merchants, reuse of the same device, IP, or payment method, or the rapid spread of fraud across loosely connected entities. And this feature enables a form of proximity-based risk scoring. The smaller the number of hops, the greater the risk. And it's especially useful for spotting emerging fraud patterns that have not yet been individually flagged, but are too close for comfort to confirmed bad actors. In a transaction network, some nodes are more central than others. They sit at the nexus of capital flows, often acting as intermediaries or hubs. Now, using PageRank, we can identify these high importance nodes, merchants, or cards that receive a disproportionate amount of traffic from other entities. And in a legitimate network, centrality is expected. Think of a major retailer or payment processor. But in fraud detection, unexpected centrality is often a red flag. A merchant or card with a suddenly high PageRank score could be acting as a mule account, part of a money laundering operation, or playing a key role in orchestrated fraud. And this metric tells us which nodes are attracting and routing value, and whether that behavior is aligned with expectations. So this algorithm is designed specifically to surface behavioral patterns indicative of fraud. We look at the transaction activity from the perspective of a card, and we're asking, is this card transacting with the same merchant multiple times within a short time window, say 3 minutes? A sudden spike like that could signal automated fraud attempts or synthetic identity use. Now, from the merchant's perspective, we ask, how many different cards have transaction here at least twice? A high number of repeated uses may indicate a compromised point of sale or a fraud hub. And these aren't just isolated features. They're part of a broader pattern. What's normal for a coffee shop may look entirely different from what's expected at a pharmacy or electronics store. So context here really matters. Now, importantly, this isn't about relying on a single feature to detect fraud. Machine learning models take a wide array of signals like these behavioral indicators and learn the optimal combination and weighting to assess fraud risk with high precision. The power lies in combining many small clues and letting the model learn what matters most in each case. Now, Sam will walk us through the fraud detection capabilities in Savannah. We'll switch over to that.
Thanks, Sebastian, for the detailed introduction to transaction fraud solution. Hi, everyone. My name is Sam Zhou. I'm the engineering manager for Tychograph Savannah. Today, I'm excited to take you through a live demo of our transaction fraud solution kit. We will walk you through the graph schema, demonstrate the building insights apps, and dive into some of the powerful queries that drive this solution. First thing first, you will need a Savannah workspace. In Tychograph Savannah, you can start by clicking the Create Workgroup button. After naming your resources and selecting a region, you can create a new workspace by choosing from the 9 pre-built Tychograph solutions designed by our domain experts for specific industries. This allows you to preview and experiment with production-grade use cases based on the Tychograph graph database with just a few clicks. For this demo, I'll be using a pre-created workspace with our transaction fraud solution kit already set up. Let's begin by looking at the graph schema that underpins our solution. The schema includes various vertex types and edge types. We will focus on the key entities involved in fraud detection, cards, payment transactions, and merchants. Cards are central to transactions and can be linked to multiple transactions, merchants, and parties. Attributes like PageRank and EaseFraud help identify influential cards and those with a history of fraud. Payment transactions are the primary events we analyze for fraud detection. The attributes provide detailed information, enabling complex queries to spot suspicious patterns. Merchants are key entities that receive transactions and can be linked to multiple cards and transactions. Attributes like PageRank help identify influential merchants, which can be crucial for detecting fraud rings. While our schema is robust, there are always potential enhancements. For example, entity resolution, which is a process of identifying, merging, and managing records that refer to the same entity across different datasets. This is crucial in fraud detection to avoid fragmented views of entities. Next, let's explore the Insights app built into the solution by default. These apps provide powerful visualization and dashboards for detecting and analyzing transaction fraud. It is a quick way to jumpstart your anti-fraud journey. You can navigate to Typograph Insights via the connector menu of your workspace. If you don't have it enabled, you can add the Insights add-on to your organization and enable it for your workspace in the Workspace config menu. The main transaction fraud app is a powerful tool that allows us to visualize and investigate fraudulent transactions, identify suspicious patterns, and analyze connections between entities. The first page, we can list the top K merchants with the highest PageRank. By focusing on these high PageRank merchants, we can prioritize our investigation effort on entities that play a significant role in the network, potentially uncovering central nodes in fraud rings. We can change the top K number to 20 to list our top 20 merchants. In the second page, we can find the closest fraudulent transaction for a given transaction. By identifying nearby fraudulent transactions, we can understand the spread and connections of fraud within the network, helping us to spot patterns and connections that might indicate larger fraud schemes. Next, the community page uses the WCC algorithm combined with centrality measures to classify merchants into different communities. By detecting communities, we can identify clusters of merchants that are closely connected within the network. This can help in spotting groups of merchants that might be part of the coordinated fraud activities. The fourth page let you find cards that have accumulated large total transaction amounts. Cards with unusually high transactions amounts may be indicative of money laundering or other fraudulent activities. This feature allows us to flag and investigate these high-value transactions promptly. Lastly, we can also identify cards that have a high frequency of transactions within a short period. High transaction frequency can be a red flag for fraud, particularly in scenarios involving rapid, repeated transactions to avoid detection limits. By identifying these cards, we can investigate potential cases of transaction splitting or other fraudulent behavior. Additionally, the ROI dashboard provides insights into the return on investment of the fraud detection solution. It includes several key metrics. The first section is about the dataset characteristics, including number of fraudulent and legitimate transactions. This gives us an overview of the transaction landscape, distinguishing between legitimate and fraudulent activities. The second section shows the detection performance. Here, we see metrics like relative precision gain and relative recall gain, highlighting the improvements in detecting fraud. We also observe a significant drop in false negative and false positive rates when using TigerGraph. The last section is about economic impact. This section illustrates the financial benefits of the solution based on the detection performance data, showing a 22% improvement on proven true positive rates, indicating a higher accuracy in detecting actual fraud cases. A 300% improvement on fraud investigation efficiency, and amounting to hundreds of millions of cost savings, showcasing the substantial financial impact of the solution. Finally, let's take a look on the queries. In transaction fraud, we have pre-built over 50 queries for you. These queries are essential for detecting and analyzing fraudulent activities. Let's start with the PageRank query. PageRank is a crucial algorithm that helps us identify the most influential merchants within our network. In each iteration, we compute a score for each merchant, and it continues iterating until it reaches the maximum number of iterations. By calculating PageRank, we can quickly identify which merchants are central and influential within the transaction network. Next, we have the WCC query for weakly connected components. This query helps us identify connected components within our graph. The query identifies groups of merchants that are connected through unredirected edges. Each merchant is assigned a component ID that indicates its community. Edges are then inserted between merchants within the same community. The WCC query helps us uncover clusters of merchants that are closely connected, therefore have a more effective fraud detection. With that, this concludes my demo. I hope this can provide valuable insights into our powerful fraud detection capabilities. I'll now hand it back over to Sebastian. Thank you.
Thank you, Sam. So we are gonna wrap up the presentation now. Give me 1 second. Here we are. Okay, great. So what we want you to take away from this webinar is that Graph is uniquely suited for fraud detection because fraud itself is relational. Relationships between parties, devices, accounts, and locations are often more telling than isolated features. With a Graph database, we model these relationships natively. And Tiger Graph stands out with unmatched experience, proven scale, and powerful algorithm. And we've delivered enterprise-grade fraud detection to some of the world's largest banks, helping them protect millions of customers in real time. To wrap up, here's a quick summary of what Tiger Graph delivers. Improved detection accuracy with over a 20% increase in accuracy, dramatically faster investigations with 300% improvement in efficiency, and significant savings that add up to hundreds of millions of dollars. And that's a win-win scenario for any organization fighting fraud. So thank you for attending the Fraud Detection at Scale webinar.